Hello students, welcome to AcadShala.
Today we are going to do numericals of chapter Electricity Part 4.
But before starting today's session, it would be great if you like this video, share this video and subscribe to our channel AcadShala. This gives us a lot of motivation to keep creating these kind of videos for you all.
The first numerical says, a current of 150 mA flows through a circuit for 2 minutes. Find the amount of charge that flows through a circuit. Now what is given in the numerical, the first point we have to see this only. So whatever is given in the numerical, we will write it. So current, that is I, is given, that is 150 mA, that is milliamperes. It is given, and the time is also given 2 minutes. So we have quoted down over here that these two things are given. But if we see in the numerical that the unit is in mA and minutes. So what we have to do, the first thing comes in our mind that we have to convert these units into the required units, which is important for our numerical. So first thing I will do that I will convert milliamperes into amperes and minutes into seconds. This is the first thing I am going to do it. So what I will do it? I will do this. Okay. Now, let me do this. The first thing comes is milliamperes into amperes. So what I will do? 150 into 10 to power minus 3 amperes. The second thing, minutes into seconds. So what I will do? That is 2 into 60 is equal to 120 seconds. So this work is done. Now what I have to do it? I will, now the next point is that what do I know? I know the formula, that is I is equal to, that is Q upon T. After this, I have written over here Q upon T, that is I is equal to Q upon T. Then what I have to find out, that is I have to find out Q. So I will write Q is equal to I into T. So now I will quote the values over here of I and T. So that is 150 into 10 to power minus 3 into 120 over here. I have quoted the values over here. How to calculate further to make it simplified? That is simplified version I have to make it. That is 150 upon, that is 1000. How this 1000 has come? That is this 10 to power minus 3 I have taken down. So this negative sign will be converted into positive. So 10 to power 3. So 10 to power 3, elaborate, it becomes 1000. Okay. Into 120. 0, 0, cut. This 0, cut. 5, 2s are 10. 5, 3s are 15. 2, 1s are 2, 2, 6 are 12. I have simplified this. In the last, I get 3 into 6, that is 6 3s are 18. So this is the final answer I got. Unit coulomb. So what do I write in the last? So 18 coulomb of charge flows around the circuit. Finished. So you need to understand over here again, children, to simplify your calculations. So you need to be little bit strong in maths. Next numerical. A total of 6 into 10 to power 46 electrons flow through a current carrying conductor when connected through an external power supply for 20 seconds. Okay. Find the value of current in the conductor. So what is given in the numerical? Let us see. A total of this electron means what? That is the total number of electrons are given in the numerical. So I will write that is n is equal to 6 into 10 to power 46 electrons are given. So I will write given over here. And time is also given. Yes. Oh, wonderful. Time is given in seconds only. So no need to do anything. So I will write t is equal to 20 seconds. Fine. What I have to find out? Find the value of current. Okay. Current question mark. So what I know in the formula, that is we know that Q is equal to NE, and I know the meaning of all this QNE. I know it very well now up till now. Okay. So I have to find the value of current. So current is over here. I know the current also formula, that is I is equal to Q upon T. But this numerical is very smart. How? That means they are telling me to use the two formulae. Are you seeing it over here, children? Yes. That is, I know Q also, I know I also. So I is equal to Q upon T. According to the demand of the numerical, this numerical says has made me helpless to use these two formulae. So if I know Q is equal to NE, I will put the value of Q, that is NE, instead of Q over here. So my formula becomes I is equal to NE upon T. Fine. Wonderful. Done. After this, I will quote the values over here. That is, N value is over here. I will write it over here. And then E is what, children? I know it already because I have understood, I have learnt it, the value of E also, charge 1.6 into 10 to power minus 19. Whether it is given in the numerical, fine. Not given, still I know it very well. Upon 20, because T time is 20. Now I will simplify the values, simplify the calculations, and I will get the answer final over here. That is 4.8 into 10 to power 26 unit amperes. Are you getting my point, children? The units are very important, otherwise deduction of marks will take place. And in the last, I will write, thus the current through the conductor is 4.8 into 10 to power 26 amperes. A conductor carries a current of 0.2 amperes. Find the amount of charge that will pass through the cross section of the conductor in 30 seconds. How many electrons will flow in this time interval? Okay. What is given in the numerical? I, that is current, 0.2 amperes given over here in the numerical. Time, 30 seconds. I have written already in seconds. No problem. I don't have to do anything now. So these two things are given in the numerical. What I have to find out? I have to find out how many electrons will flow in this time interval. So what I will do? So I know that current is equal to Q upon T, and Q is equal to, I will multiply I into T. Okay. Then I will quote the values over here. Current is 0.2 amperes written already, given in the numerical 0.2. 30 seconds time, I will write it 30. I will simplify. I get the answer as 6 coulombs. Done. Okay. Now I have to find out how many electrons. Until or unless I get the I value, I cannot do anything else. That is, if I do not have the Q value, I cannot do further anything else. So I have all the values, I've quoted the values, I've taken out Q over here. Now, I also know the formula, that is Q is equal to NE. I know it already beforehand. Then what I will do, I have calculated this Q value, 6 coulombs. I will quote this value over here, 6 is equal to N. I have to find out electron charge. I know it, no matter it is not given in the numerical, but I know it myself beforehand. I will put the value 1.6 into 10 to power minus 19. Then I will take out N value, that is N is equal to 6 upon this 1.6 into 10 to power minus 19. And then what I will do? I will write this 10 to power minus 19 up to bring negative to positive. So 10 to power 19, and this 1.6 which was written over here, to remove the value of this, means to remove this decimal point, I have put 10 over here also. So this 6 becomes 6 into 10, 60 upon 16. Then I simplify further and then I get the value 3.75 into 10 to power 19 coulomb. This is the way, children, you should know how to calculate, how to remove the decimal place, what you have to put it above, how to remove this negative to positive, where to get these tens, and the numerical is solved. So simplify the things. This will be simplified and then you can do it very well without doing any mistake. So all the values, see children, of this beta, electron, that is electronic charge, you should know. It is not given in the numerical. So you should know this on your own. Are you getting my point? Whatever is not given in the numerical, but you should know it very well. Because we consider that these values should be known by the student. So, I wind up the session today, children, with this numericals. Keep on solving the numericals. After you have seen this video, pause the video and then solve it on your own. Only to see the answer or the calculation part or the steps which I have followed, then you tally it, but please do it on your own with your hands. Oral work will not do anything. So thank you so much, children. God bless you.